Good morning. I'm going to go through the review. Uh, it may need to be in a few different parts because Screencast-O-Matic only lets me do 15-minute videos for free. So we're going to start at the beginning, get as far as we can, and then I'll open a new video. So the first set of problems say find the inverse function, restrict the domain if necessary, and graph the function and its inverse on a grid. Now, truly, we need a little more room here, don't we? So I wonder, I'm going to give myself a little more room. You don't have that when you're working on, well, if you're working on the tablet, you can do that as well, right? So if I want to find the inverse function, my first step is replace f of x with y, right? My second step is switch x and y. My third step is solve for y. So notice I'm going to multiply by 10, so I get 10x equals y squared. Now, I'm going to run into an issue here. This is a quadratic. If I try to find the inverse function like this, I'm going to run into an issue. So, I have to restrict the domain. And remember, I restrict the domain to 0 to infinity. Okay, now let's finish. If I take the square root of this, y equals just the positive square root of 10x, right? My final step really is to replace y with f to the negative 1, which indicates inverse function, right? So I can graph these, and when I graph these, we'll see the range. We want to find the domain and range for the original function. And once we find the domain and range of the original function, we will know the domain and range of the inverse. So I'm going to come over here and I'm going to graph 1/10 x squared. And I'm going to look at that on my calculator. Now, because I restrict the domain, notice there's no negatives here. So it looks something like this. I'm going to go to my table. All right, 0, 0. And then it's mostly, of course, decimals. But let's go to 3 is 0.9. So that means it's going to be right about here. And 5 is 2.5. Let's try that. Okay, so this, right, is my original function. Now my inverse, I'm going to graph that on the same 10x. I'm going to graph that on the same graph so I can see it. I'm going to look at my table. It looks like sense check. It looks like an inverse function. All right, so let's do this one in red. So it's 0, 0. Okay, well, let's get to it. 3 is 0.9. Notice that's the same point. Oh, I'm looking at the wrong one. Jeez. All right. 3 is 5.5. So I'm going to go to 3. I'm going to get 5.5 like this. Let's go to about 8 and see what that says. So I get the right shape on this graph. 8 is almost 9. So 8 to here. So there is my inverse. Okay? And it does say graph 3 points minimum. And if I ask you to give me a XY table, you can do that easily. So the range in this case is 0 to infinity as well. All right, let's look at the second problem. The second problem is a cubic, which guess what? I automatically know my domain and my range, don't I? Okay, so I'm going to find my inverse. So y equals x to the third minus 2. Y plus 2 equals x to the third. Cube root, right? We don't have to worry about Oops, I forgot to switch x and y, but that's okay, because I got it right here. Alright, so the cube root of x plus 2 is equal to f to the negative 1 of x. So let's graph it. Notice the grid here has negatives and positives on it. So it's kind of giving you a little clue there, isn't it? So I'm going to graph x to the third minus 2. Whoops, minus 2. I'm also going to graph the cube root, so I have to hit my math button and use my cube root of x plus 2. And let's graph it. Alright, I'm going to look at my table. It's thinking, it's thinking. Looking at my table. As soon as it opens. There we go. Okay. So I'm going to come down and look at negative 2 is a negative 10. Wow, that's down here. Okay. 0 is negative 2. 1 is a negative 1. I'm trying to get the shape of it. 2 is 6. So it looks like this, doesn't it? Okay. Now, in red, I will graph its... So negative 2 is 0. We're going to have to look back and get the shape. Negative 3 is negative 1. Negative 10, which is over here, is negative 2. Alright, let's look. 0 is negative 1.25. 0 is about here. So this is going to do that. So there's the inverse, and there's the original function as well. Okay? Alright, now I don't want you guys to look at this problem and get overwhelmed. It's giving you an equation here, okay, for how a spring scale works and how you can calculate such and such with Hooke's law. When it says find the inverse model, when you have a word problem, you don't have to switch x and y. You basically just solve for the other variable. So if I have L equals 0.5w plus 3, I'm going to solve for w. So I'll do it like this. L minus 3 equals 0.5w, right? And I kind of like 0.5, I'm going to write it as 1/2. So then if I multiply both sides by 2, I'm going to get 2 L minus 3 equals w. All right, now it says if you place a melon on the scale and the spring stretches to a length, how much does your melon weigh? So this just allows us to take w equals 2, 5.5 minus 3, okay? Your weight will be in, it's going to give us, right, it tells us in the problem, inches and pounds. So if I calculate that, it should be 5, right? 5.5 minus 3. Just double checking so I don't make a mistake. So it should be 5 pounds, right? Not a big deal. Don't let the wording overwhelm you. All right. This is similar. The function here gives the volume of a sphere with radius r. So the volume is based on radius. Now it says, well, express the radius as a function of the volume. So now we're going to solve for r, right? V equals 4/3 pi r cubed. All right, well, I'm going to multiply both sides by 3/4, right? 3/4v equals pi r cubed. I'll divide both sides by pi. 3/4 pi, pi's in the denominator, v equals r cubed, take the square root. R equals that, okay? Find the radius of a sphere with the volume of this. Let's go back and double check. Whoops. Okay. Find it the nearest centimeter. Okay. So the radius is, whoops, the cube root, right, of 3/4 pi times the volume of 288. So I'm going to put that into my calculator. 3 divided by, in parentheses, 4 pi. Need my light on here to see what's going on. All right, then I'll multiply by the 288. Then I'm going to take the cube root of that. And I get, they want it to the nearest tenth of a centimeter, so it's going to be 4.1 centimeters. Okay? All right, moving on. It says identify and describe the transformations as well as the domain and range. I'm going to bring this to the next page. So, we're going to need room, but let's see what we can do. I'm going to start with 5. Let's look at our transformations. Well, A is 1. Nothing to worry about there. B is 3, isn't it? H equals -2. K equals 1. So if I describe those transformations for 5, right, B is 3. So that means a horizontal stretch by 3. And all H is -2 means it moves to the left 2. K is 1 means it moves up 1. Okay? So now we have to find domain and range. Remember our rules or our process there. We're looking just at 5 right now. So I have to take what, for domain, to take whatever is under that square root and make sure that it's greater than or equal to 0. All right, we're going to multiply both sides by 3. X plus 2 is greater than or equal to 0. Subtract 2. X plus 2 is greater than or equal to -2. This is my domain, written as an interval notation, or in interval notation. Looks like this, doesn't it? So there's my domain. Put it on your calculator, see if it makes sense. Okay, then the next thing I do for range, we're going to need a whole page for this problem, won't we? Or this set of problems, is I start with this thing. I know that this has to be greater than or equal to 0. Now I need to manipulate it to get it to look like this. So I'm going to add 1 to both sides, okay? Isn't this y? Y is greater than or equal to 1. That's my range, written in interval notation. -1 to infinity. Now, can you look on your graph and check it? Sure. All right, I'm going to graph this now. It's square root, whoops, that's not what I wanted, square root, 1 divided by 3 times x plus 2, click out, plus 1. All right, let's look at our graph. Oh, it makes sense. My graph, gosh, here we go again, okay? My graph for this looks something like this. It makes sense. The range, oh, that shouldn't be negative, should be 1. The range is 1 to infinity, and the domain is -2 to infinity. Okay? All right, I'm going to stop this video here and start the next one on number 6.